乡的波霜，窗前的月光，都照亮心底某个地方。有人用思念两段足石行，流淌过1000年，恋恋难忘。你有绿树红墙，寄握着风霜，也有草场白云白，吹到长城长。天水煮小巷，早上老火汤，在家3分时光，坐在门前慢慢唱。人间烟火山河浩荡，清风过大江，水路弯弯连海浪，两岸千里的花香。你爱的人啊，记得你最好模样，你是高高的忠贞，是心之所向。时代滔滔向前，温柔而勇往，留不我梦中的你，花开遍山岗，蹒跚着成长，离开又回望。你是年也是乡，是冬眠的歌堂。人间烟火山河浩荡，大雪落夕阳，午夜钟声是响，一缕吞咽的泪光。你爱的人啊，永远放你在心上，就算已白发苍苍，也别泪目。人间烟火山河浩荡，你任我去闯，多少个还会东望，最远最近是家乡。我爱的你啊，泪落千年的时候，挽着小小的跟我靠近。Hey ya! Thank you, Emergency Milk, for subscribing. Oh, actually, I think you are the last one that unlocked the founder status. Yeah. Welcome back to another day of suffering. Continue from last time, we started the 2-pointer pattern, so we're gonna continue move on to the next question in here, which is I go next. Okay, squaring a sorted array. Given a sorted array, create a new array containing squares of all numbers of the input array in the sorted order. Example -2. 4. Oh, okay. So -2 square is 4. 1 square is still 1, but it will be positive number. Okay, so normally people would just would do the square and then sort them, but that's the complexity of this one is O to the log n, because the sorting cannot be O of n time, so it's O of n log n. What we can do is if there's a negative number, why is the Twitch so confusing to use? Because they have much stuff that I don't know about. They have a lot more. They have a lot more stuff than YouTube. So what I need to do is basically find the smallest number and then start from there. Hello hacker, I'm not a hacker. Okay, we set a default number and we want to move until we find the smallest number, and then we start moving left, right. Right? So for let I equal to 0, I less than array dot. Well, they already have a length there, so n y plus plus if smallest is actually no, this we want the absolute value. I think yes, absolute. I think it's math dot absolute. Yeah. So math dot absolute. We just care about the absolute value. So if the smallest is greater than the current value, array I, then array I is the smallest. Then do a temp. M is equal to math the absolute array I. Right? So if the smallest value is greater than the temp, then we have a new smallest value. And what we want to do is left is equal to I, and then right is equal to I plus 1. So in this case, at the end we will have left is here, right is here. So we traverse this once, that's the log of n. And then we start moving left, right. I feel that I can combine this all in once. And then we'll make a new array. Array to equal to array. While array to dot length is less than 0, less than n. Math square. What is it called? Math square. Array to dot push left. What is as we know the smallest number is usually in the center, so array to push left. Left is the index array left. Math dot square left. And then left minus minus. Like if array left is math dot absolute, is less than math dot absolute. This can be left or equal. This doesn't matter here. Array right. So we want the next smallest number. So if it's less, then we're gonna do array to push left. Otherwise, we do array push right. After we push left, we're gonna do left minus minus 1. Left and then right fast. So this has to be like this. descending order because you want the square. You want the output to be also a increasing order. But the input can be negative, but square of negative is positive. So we find a small number and then traverse left right. Like this should be fine. However, there's a problem is that we can have a right number is always less than absolute of left number. So we don't want to go out of bound. So how do we do that? If right is equal to array dot length, then we only want to do left. Like we only want to do left. And if left is equal to 0, we only want to do right. Like here. Else if, and then else if. Like run this. Run. My output is 0, 0, 0. Why is that? Console log left, console log right. Left is 1, right is 0. Left is 0, right is 2. Left is 0, right is 4. Why left doesn't move? Input is here. Left and right are both 1. That's not good. So I equal to 0, I less than, and I plus plus. Temp is equal to math absolute array I. Array I is here, math absolute. So this is 2, right? Temp is equal to 2. Oh, because we don't have a temp. We don't have a beginning temp too. Okay. Let's initialize 10. So both smallest and tangent equal to the same thing. Now run again. Still 1 and 1. Whoa. So let's console log this. Math absolute is 2, right? This is fine. So we have 2, 1, 3. This is correct. Wait, no. Yeah, 2, 1, 3. This is correct. So The current smallest is 2. Smallest 2 is not greater than 2, so this skips. 1 is not greater than, skips. 2. Next one is 2. How is this 2? XR should be 0. Math absolute array I. How is this 2? Math absolute 0 should be 0. Math absolute 0 is not 2. Array I. So negative 2, 2, 1, negative 1. Why is it negative 1? Oh yeah, negative 1. And then 2. Why is it 2? There's no... Why is this 2? Math absolute value of 0. Why is it 2? Console log array I. Also log array I is 2. Why? Why the input is 0 here? It's array 1. I mean array 2. This doesn't make sense, guys. So if I traverse this array, right, it should print out the same thing. -2 -1 0. So now it's correct. Now this is correct. So math absolute I is somehow 2. Right, there's something going on there. There's something going on. If I remove this, this is what I want. This is the correct one. But then... Okay, no, it's correct. Okay, something here. Something happened here. 10 method. If smallest. Smallest is math absolute array 0. Temp is equal to math array 0, so this should be equal to this. Oh, okay. I plus 1. Because I think I plus plus, this is actually increments this, I plus plus is equal to I equal to I plus 1, so I shouldn't do I plus plus here. Oh, now it should be correct. Okay, now it's correct. Now if I continue this, it's still 0, 0, 0. Oh, that's fine. At least we fixed one problem. Two and three. So now 2 is here, 3 is here. This is correct. So left, we're gonna push left, which is 0. We push left into the array, and then we move left to the left. Actually, I don't have to do that. I don't even need this. I don't even need this part. Okay, so now let's see. So this is comparing left and to the right. Right, so we just need to console left and right. Zero, 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 not numbers. Oh wait, my glasses wonky. And the take out the glasses. Boom. You just feel square with 0 in the start of code. How? Less square equal to array and fill. Oh, because it's returning square. Oh. Array 2. That's crazy. Okay, at least we get it somewhere. Oh, this is not my field, but this is the program. The program did it itself. It was already in the program before I do anything. Okay, at least we're making some progress. Math absolute left. Math absolute is 2. Right, so this should satisfy. Array push. So if left is this is 0 compared to 2, right? So they should push. They should push the 0, 0, right? And next one is 1 and 2. 1 and 2 is 1 and 2. So comparing 1 and 2. Absolute 1, 2. Is left is still gonna be absolute of -1 plus compared to absolute of 2. So 1 should be array should push array left. Left is 1. Square of -1. This should push square of -1. But it's no. Are you supposed to return square? Wait a minute! Square root! I was doing square root this so bad. Don't wonder why. Okay. No. God damn it. Why am I doing square root here? So this just needs times itself. Oh, no wonder why. No wonder why I'm getting all those weird numbers. So left times left. And then this will be right times right. You see, I have more reading problem than logic problems. Okay, now we just need to just one number is off. Not a number. Last one not a number. Zero 2 1 2 2 2. 2 2 is why don't I just do left and right? New outfit, yes I have a new outfit. I'm a JK now. Okay, one of them went hollow bound. Oh, less than equal to n. One again. You know. Wait, no, I shouldn't run again. Zero 2, right? And then minus 1 2. Minus 2 2. That's correct. Minus 2 and 3. That's also correct. Minus 2 and 3. So this is this comparing to this. That's correct. Oh, I see. And then minus 2 3 is undefined. Minus 2 and 3. Minus wait, minus 2 and 3. Minus 2 and 3. The progression ended here. Still continues. While less is weighted down less than 0. And right is less than or equal to n. What is the last number? Undefined. What does down band say? It says say the guy. School council. It means school council. Oh, I'm stuck at easy question. How am I supposed to get a job? What about this? This left, this going left plus minus mass. If left is greater than equal to 0, else that means I can remove this. So 144, right? No, 1449. It's ran one more time. Okay, cool. Okay, wrong. This is correct, right? This is wrong. 302. Wait, 302. Wrong. The last one is no. All of these went out of bound. If less left is less. Zero is correct. One is correct. 0, 1 is correct. 1, 1 is correct. 1, 2. 1, 2 is correct. 2 and 3. 2 and 3, that's correct. I mean 1, 2, 3, 2, 3. Not number 3, not a number. This ran extra time. I don't think this is gonna work. Yeah, this is not working. No. So 3 they went overboard here. I mean 2 went overboard. They 3, 9. 1, 2. 0, 1, 0, 1, 1, 0, 2, 3, 2, 3 and 2. 3 and 2 is here. What's the point sorting and squaring the array? We want to, well, a sorted array, you want to make a square of 4 numbers also in a sorted array. Basically, we can easily just square everything. We can square everything and then we sort them. However, the problem is if we square everything and then sort them, the time complexity is n times log of n. Right now I'm trying to make a time complexity of n. So n times log of n. That's why I'm doing all these extra steps to make this program as efficient as possible. Array left. How am I stuck at this? Why am I stuck at this? Math left. Three and 2, they should be ended here. But then there's 3 and non-number. They valid one more time. I would say not just one more time, but it's 1, 4, no. Oh, 1, 1. So 1. The first iteration is comparing 0 to 1. 0 to 1, that's correct, 0, 1. So this trigger left move here. So now we compare 1 to 1. So 1 and 1, this is correct. Right? Because 1 and 1, the first thing triggers -3. Oh, so So now it's -3 compared to 1. Oh, I see. I see what's going on. So instead of doing this, we could do if array with math absolute array less -1 is greater than if left is less than math absolute array right +1. So instead of moving to 3, because right now it's comparing 1 and 1. Instead of moving to 3, we do left and mass. Else right ++. Then we remove this part. No. God damn it. Does it not have a built-in sort function? It does have a built-in sort function. The built-in sort function is log n, big O of n times log of n. It is allowed, but it's not the most efficient. Well, I'm not creating newly efficient sorting. The reason why you can do it more because the pre-context is that the input is also sorted. That's why we can do that. I'm not recreating another sorting that uses log of n. That's not possible. Mathematically, that's not possible. We can do that only because the input is sorted. Wait, you know what? I have a smart idea. Why am I doing all this? I don't need to do all this. Okay, so I'm gonna make a new array. Right, this finds all that. Then we run into the same problem. You think I'm overcomplicated? I think so too. I can do log of n times easy. I mean n times log of n. So for that, well, I can just do the same thing here, right? The rate to push array I and array I. So this creates a new thing, and then sort. And then we just return with array to sorts. You see, this is easy. I mean, if I just do sort, that's easy. Wait, hold on, that's not easy. If I sort this, why is 16 before 4? Why would 16 come before this from the sorting? That's cheating. I told you it's like I can't. If I want to make it as efficient as possible, I can just use. If I don't need to make it as efficient as possible, I can just use the sort. But why would the output be like this? Oh. Wrong. Why would 16 come before 4? Why is the sword not working? Is the sorting thing broken, or they purposely make it broken? Wait, no. That was accident click. Right after this number 164046. So after I saw be 0441616, but it's actually 0161644. A and B, A minus B. Oh, so negative positive number. But why default sort doesn't do that? What's default sort doing? Also, this is not the most efficient. A minus B here works because if A is greater than B, this is a positive number. It takes A. If A is less than B, this negative number. So it takes B. Right, so it was comparing to actually I don't know. How does this sorting work? If A is less than B, the result is negative, so A placed before B. Yeah, that's what I think it is. But there should be a more efficient way to do this. We can use brute force, iterate, calculate square, and then we saw this. Yeah, so you see this what I mean? Is n times log of n. So what I did was n times log of n. That's a brute force. Can we do better? Yes, we can. Can we? Yeah, is it possible? Yes, that's we can. I was trying to do that. The tricky part is we can have negative number in the array, which makes it harder to generate output array with the squares in sorted order. One easy approach is could find we first locate the index of first positive number in the input array. After that, we can utilize two-pointer technique to iterate over the array. Yeah, that's what I was doing. So I find. Oh, can you see that? I find the first 0. Yeah, I find the first 0. And then I iterate left, right. That's what I was doing. Since the number of both ends can give us a large square, an alternative approach would be use two-pointer starting at both ends of the input array. At that step, whichever the pointer gives us is the biggest square. We add. Oh! That was easy solution right here. So instead of push right, instead of push right, we could easily do. We put a pointer to the left, put a pointer to the right, and then we find the largest number and then we push to the end. So instead of doing push, we can do shift. So the next number will shift. Next number will shift. In the end, we'll end up with that. Use 2 pointer at any step which her pointer gives us the biggest square. We add it to the result and move it the next number to previous number. Please note that we will be appending the biggest square and opposed to the previous approach because the 2 pointers are moving from larger square to smaller square. For that, we will be inserting the square at the end of the inputs. This will be much easier to do. So we start from one end, and then we have one pointer at one end, and then second pointer at the other end, and we just square this. We square this and we see which one is bigger. So in this case, this is bigger, and we push to the array at the end of the array. No, push with the shift. Wait, it's not shift. Append to the array. And then because this is moved, so we move pointer 2 to the left. And then we compare these two. And then whichever is bigger. Oh, in this case they're both same. Let's say we're doing the left ones. We append the left one and then we move left to here. And then we compare these two. And this will be the bigger. We append that and then move to the right left. And then we compare. And then compare and move to the right until this gonna be a while loop until if the pointer 1 index is not equal to pointer 2 index. Eventually they will meet at the middle. Right? After they meet at the middle, we push the last number. Actually, we just need to meet at the middle. We do that if pointer 1 is less than pointer 2. So this will move here and this will be bigger than this. So just do a while for that. That would have been much easier. God damn it. Now look at the solution. So long. Next. Yeah, that's what I was trying to make it all of n. And then people will be like, why don't you just sort it? Because if you sort it, it'll be all of n times log of n. Okay, next median. I don't have hope anymore. Even the array of unsorted number, find all the unique triplets in that. That adds up to 0. Wow. Find all the unique triplets that adds up to 0. Okay. We can still do this with 2 pointers. So, the first thing, I think in this case, I do need to sort this. I need to pre-sort this. Array equal to array sort A, B. A minus B. Let's left the 0, right for 2. Left equal to 0, right equal to array dot length. While left is less than right. If absolute math absolute left is greater than math absolute right. If left is greater, we start with left. Pointer left would be right. If we sort this, we start with the biggest negative or biggest positive number. We look at the biggest negative or biggest positive number, and then we find the third number that fits in. Right? That's the right approach, right? And then we can have m equal to 0. While 10 is less than left. 10 equal to right. Go to right. And less is greater than. So 10 equal to right. If array left plus array right plus array temp right means 1. If these are equal to 0, then we found a triplets equal to left and right. Right, after this is fine. Found. Regardless it's found or not. Because the biggest number, if the biggest number cannot find one, then we just increment it. Right. So next we just need to reverse this. Oh no, it's less than. And now it's right plus plus. And now the 10 is left plus 1. While 10 is greater than. Like this. While 10 is greater than left. And 10 is less than. Less than right. I 10 is left. So 10 minus. And this would be 10 plus plus. Right. See, I mean, if we have it in a loop here. First, we sort this. And then while left is left and right. M equal to left transpond. Well, 10 is less than right, 10 plus plus. Oh, if we find a triplet, then we just break. Find triplet, we break. So, forget about counter for now. Infinite loop. Let's see, test case. I'm going to comment out these parts. I'm going to console log array. Okay, now we can work with this number. So left is 0, right is a radial length. While left is less than right, that's correct. So the first one will trigger math absolute left. We are comparing these two. If this is bigger than 2, that's correct, so this will trigger. And 10 is equal to right. Right here is oh, left right. Fuck. Array left right. I'm just comparing I'm comparing to the freaking index. That's why. So left right is greater So now 10 is equal to right minus 1. So it's this index. While 10 is greater than left. Right, so -3 plus 1, 2. This should be equal to 0. So the tubular will be the 3. Whole tubular should be... I think they're asking for numbers. The tubular should be array left, array temp, array right. Runt. Alive in the loop. Let's do this again. Runt. Get this number. Okay. So while index of this is less than, the first one triggers. So actually, that's why I have a count yet. And count is less than 5. Down plus plus. What I want to see here is let's run this. Output is nothing. Oh, there's no console log here. So it didn't even trigger. We're about here. It didn't even trigger. So why doesn't it trigger it? Math absolute left. Array left. Left is 0. No number, no number, no number. Array right is not a number. Left -1. Okay, we're getting somewhere. Because array dot length. Okay, the array dot length was the length not accounting starting index 0. So this array dot length would be out of bound right away. Steering from the loop. 312, 312, that's correct. Break. That's also correct. However, wait, oh, break. Oh. Wait, break doesn't matter. Break only breaks out this while. After breaks out while left plus plus. Well, it did find the first. It did find the first. Correct. So 3 and index 1. Index 2. Wait, hold on. Oh yeah, 312, that's equal to 0. So this is correct. It found the first pair. It just somewhere along here makes the infinite loop. Right, if it's not greater than if I increase the count here to M, will you find the next one? Nope. So this one finds the first one. It finds the first one, it pushes the first one, it breaks out. And then left plus cross. Left is now here. So if left less than right, this will continue. So math absolute, left, right. Oh, so this won't trigger. This won't trigger, so left 1 plus plus, right 1 plus plus, okay. What of these need to be equal to? Okay, now it finds the second pair. Good. Now if I remove the counter, infinite loop. Okay, keep going. See, now it finds the second pair. Oh, they want me to push it like this. Okay, I'm gonna push it like this. That's easy. Easy peasy. Easy change. So if I run again, so the first half is correct now. Need to continue to not go into infinite loop. Right. We find a second number. So now it will be 2, 2, and absolute is equal to. This will be equal. So we keep going down. 10 is now equal to 2 minus 1. Oh, maybe because 10 is. No, that's still fine. So 2, 1, 2. Well, 10 is greater than left. We're gonna try to add these three together. It doesn't work. Well, now it doesn't work. And then with 10 minus math. So go to the next one. It tries to add them. Doesn't work. You go to the next one. So 0. 0 works fine. So 0 works fine. We push and then we break out this. We break out this will be left mass. Left plus plus. So the left is now here. Right? And then next we compare noise 1 to 2. So 1 to 2. So this part will trigger. Now 1, 2. And 10 will be left plus 1. So it's 0. So while 10 is less than right. Right, so array left plus right. Left plus right. 1, 1, 2. Okay, see almost. Oh, you can see almost. 1, 2. And then 10 will be 0. So 1, 2, 0. That's that does not equal, so 10 plus plus. 10 plus plus will be 10 is equal to 1. So 1, 1, 2 is not. Then it's not equal to 0. 10 plus plus. So 0, 1, 2 is not equal to 0. 10 plus plus. Ten plus plus now. Now 10 is equal to right. 10 is equal to right. So this will break out. This break out and then right will plus right plus us. Oh, right plus plus right minus minus. What the hell? Okay, we found 3 pairs now. We're missing 1 pair here. And also we're no longer infinite loop because we're doing right plus plus. This will always increase this number, so it's gonna infinite loop. Okay, we found out we're missing 1 pair. 2, 1, 2. Negative 2, 1, 2. 2, 1, 1. 2, 1, 1. Negative 2, 1, 1. Oh, I see. We found 1 pair and then we'll move on to the next. But there are 1 more pair on this number. So if I don't do break here, this will continue. Once we found the triplets, push and then do the 10 minus mass again. And we continue to do. Oh, I see. Instead of doing that, we also need to move right. Because this one, currently, the second iteration right is here. 10 is here. We also need to move right 10. Ugh. Okay, I need to batch this. So for let I equal to 0, I need to traverse from this to the other one. And I less than so in this case we don't even need to sort it. Array by length I plus. So we're still gonna have left and right. So left will be equal to I plus 1. Right is equal to array dot length. While left is less than right. So we do the same thing here. Instead of left, right, we have an I. And we push I. This is if they are equal, right? So else if that m is equal to this added together. If temp is equal to 0, we found the triplets. But if temp is greater than 0, if it's greater than 0, since it's sorted, the rightmost number is the biggest number. So we minus the biggest number. Else we plus the smallest number. Left equal to I plus 1, right equal to array of length. Oh, I need to traverse that. I need to traverse the other way too. Left equal to 0. But then it cannot be I. So -3, -2, -1, 0, 1, 1, 2. Index I is here. We make the leftmost number. Left is here, right is here. So we add them together. If this is too big, if this is too small, we move left. If it's too big, we move right. Eventually we'll find a whole number. And then I increment I. I can do left right again. I just need the left cannot be equal to I. If left equal to I or right equal to I. Oh, what about this? Left is always equal to 0, right is always equal to length minus 1. Right? But if less is equal to I, then left first. Or if right is equal to I, then right should be minus. What about that? I is 0, I is 0, left is also 0, but left is equal to I. So we move left to the right. Else if the right is equal to I, we move right while left is present right. This should be fine, no? I is 0. Left equal to I. Left is 0. If left is equal to I, then left should be here. Right is here, left is here. So while left is less than right, we try to add these together. If there's 0, then we push. If there's 0, then we push. Otherwise, if they're greater than 0. So 3 plus 2 plus 2 is less than 0. If it's less than 0, we move this number up left plus us. And then we try to add them together again. So 3 minus 1, 2. And that's also not 0. It's still negative, so else if 10 is greater than 0, it's not. So else left plus plus, this plus plus. So negative 3, negative 1, that's still not. So this should still be plus plus. So negative 3, 0, 2, plus plus, negative 3, 1 and 2. Negative 3, 1 and 2. So this should be equal to 0. So this should push. I left, right. I left, right. This should push this. After this is pushed, it has to do something, okay? Otherwise, just keep pushing. After this is pushed, because it's equal to 0. I need to either left plus or some right math. If they're equal to 0, the next number has to be on the left. Because this is sorted. Next number has to be from left. So left plus will be, because we know right is always greater than left. But the current left can be equal to the next left number. That's why we push left. So this should break out from the. This breaks out from the infinite loop. It does break out from the infinite loop. However, the problem now is we find too many numbers. Oh, because it finds multiple times. It finds the number multiple times. So I don't even need to do this anymore then. If I don't do this, is not defined. That's correct. Zero. What if a race always starts 0? We just turn left and right. Well, left is hem is equal to this together. Left is equal to, actually no. So if we make left always equal to 1, what about this? I give up. Hey guys, I give up. Its problem follows the two-point pattern and shares similarities with pairs and target zone. A couple of differences are the input array is not sorted, and instead the pair we need to find triplets with the target's sum of 0. To follow a similar approach, first we need to sort the array and then iterate through make one number at a time. Let's say during our iterations we add number x, so we need to find y and z, such x, y, z equals 0. At this stage, our problem translates into finding a pair whose sum is equal to minus x. As such, or y plus z equal to minus x. Our difference from that pair with the target sum is that we need to find all the unique triplets to handle this. We have to skip any duplicate numbers. Since we'll be sorting the array, so all the duplicate numbers will be next to each other and we then are easier to... Oh well. I need to skip the number. You see, I also freaking misread the problem. Unique triplets. So if we have one of the one is pushed to, I should just skip that. So previously I had this. Previously I had if left equals right. If I just skip that one, instead of doing left plus plus here, right, I just break out. No breakout. I just skip the next number that's equal. Well, the only problem with this approach is that they want us to add a number from left to right. So we are traversing through I. We don't know, like in the program itself, we don't know whether actually, yes, we can. So if left is less than I, then we put I into left. We put left into left of I. If left is greater than I, then we put I before left. Oh, that can do it. Step by step. We'll pair target signs that we define unique. We skip on, yeah. So the array, I did that. Retest through the array, I did that. Use a for loop iterate through, stopping at the third to last element. For each element, checking if it's the same as previous to avoid duplicates. If it's the same, skip the next iteration. Fix the current element and find pairs. Fix the current element, find 2 pointers. Find pair whose sum is the negative of target sum equal to negative array I. The left pointer starts for I plus 1, I did that. Find pairs with 2 pointers. Calculate the sum of left pointer and right pointer. Left, right. If current sum is equal to that. If current sum equal to left, right. Error sum equal to target sum. Add the triplet to the list. And move pointer to the next unique number. Move both pointers to the next unique. Both pointers. If you find one, you move both pointers. Why? To the next unique number. If current sum is less than target sum, move left. Okay, I did that. If current sum is greater than, move the right pointer. I did that. add the triplets of list and then move both pointers. So what I was doing here was correct. What I was doing here was correct. So left equal to 0, I. Left is I plus 1. Right, left is I plus 1. Left is I. Left is I plus 1, right? So we do I plus 1 because we don't want. If we were doing like if I doing what I was doing previously, here we reset the I always. We will run into the problem is that we will find multiple same pairs. Right, so left is equal to I plus 1. Right is a length. And if 10th. So what I was doing up to this point was correct. The only thing that was missing is that I kind of misread the problem here. Unique triplets. Unique triplet means that I thought the unique means like. Oh wait. Oh, it can't be 1 2. Okay, never mind. So we want the negative array I equal to left plus right. Well, 0 is fine. 10. If 10 is 0, oh, this should be I. And I. So left plus. If you find one left plus right minus. Otherwise, if it's greater, then we move right. Oh! What the fuck? I had it. Oh, I almost had it. Okay, now the thing we need to take care is the next number cannot be equal to the previous number. Left right cannot be equal. You see, that's what this is what I had earlier. Only thing I added here is just right minus. So we need to move both pointers, not just one pointer. Okay, now this is the problem here now is there's a duplicate here. So what we plus. What we plus, the next plus number cannot be equal to the previous number. So function left. If array left equal to array left plus 1. Then we return left plus 2. Otherwise, it cannot be equal. It could be okay. Here the issue is left 1 could be equal. These two number can be 1 and 1. However, there's no guarantee that left plus 2 is also not equal to 1. I wonder how they solved this. Both array. Input is here. After sort it becomes this. I starts here, left is here, right is here. Target sum, okay. This is greater. If you add it together, this is greater. This is less than 0. So we move left to here. And then we compare. We compare this number. Compare this number is less than 0 together. We'll move left pointer. So now this is equal to 0. This is equal to 0. Add it to triplets. Do left minus 1, right minus. Left has right has. Now these two will reverse. That will break out of the loop. So next one, I will be here. Left will be here, right will be here. Add them together. Is equal to 0. So now you do this. Right is greater than left, so I minus 1. We go to next eye. Yeah, that's what I'm doing. That's exactly what I'm doing. If they're 0, push them. If they're greater 0, move to right. Move right. If they are less than 0, move left. This creates one duplicate. This creates one duplicate. Oh, it's 0, 0, 0. High equal to here. The first side, we will find the first one. We'll find the first one, then left plus first. Right mass. This will break out. So next eye, left equal to I plus 1. Next I is here, left is here, right is here, while left is equal to right. Oh, while left is less than right. Which shouldn't be like this. I just have a freaking duplicate here. So they sorted this. Okay, that's right. Iterate from iterates array. That's right. If I is greater than 0 and array I is equal to array I plus minus 1. Okay, so if this is not a first iteration and the array I number is equal to the previous I number, then we continue this. If I is greater than 0 and I is greater than 0, the array I is equal to the previous I number, and we continue. So for this duplicate again. How am I gonna duplicate? Then continue. Continue is equals to next one. I plus plus. And then they search pair right is equal to this. Where did you get left? Left is I plus 1, okay? Then same as I did. Current equal to this. If it is target sun, we pushed, yeah. Left plus. So this same as just left. Left plus minus 1. While oh, skip the element. That's how you skip the element. While left, it's less than right. Oh. While left is this is a binary. While right is equal to right. No, while array right equal to array right plus 1. Now we keep doing this. Right minus minus. And then this is how we skip duplicates. Array left equal to array Left. -1. Then we do left. That's us. While left is less than right, and while left is left than right. Submit. I still have a duplicate here. What if I add here too? Oh, since I'm in here, why don't I just do this? If I just... If I just put this outside, so this will always run. Okay, now I'm missing one number. Oh, wait. I'm stupid. I don't know. I don't think that matters. I don't think this matters. I don't think it matters, but let's try. Yeah, it doesn't matter. You found a triplet. Congrats. So left plus, right minus. While this, left plus. While this, left plus. Oh, you only do it. Oh. You only do it within the current. You only do it within the current found pair. Dong. Oh my god! Solution accepted. You only do it if you're within the found pair. If you do it without the found pair, I will go to the next. Oh, because if we iterate through array, if we iterate through the entire array, the I and the previous I could be duplicates,
And if we don't, and within the iterations, we have a while loop that checks left and right. And if we don't skip the duplicates, it will create a duplicate. It will create an additional send number pair. Create additional send number pair as if we iterate through I. Because the next I would be one of the I that has duplicates. So we push the if left right is send number while the I doing the one I iterations, the next I iteration could be landing on that send number. Oh, I see. I see. Hey guys, what we learned from this? What we learned from this is that Eudemon is actually not genius. Anyways, I'm gonna take a break. And I think after this I'm gonna play Resident Evil. So, see you guys later. Bye bye.雅思族破门而开，之间谦虚半步，一人曾举目，孤行伫立待的日当正中，等教文具藏花壶，第一口难辨是非，唯有墨鱼之术，盘中人杰的正业户，耳鬓闻情伤风骨。生者一寸，一方便言和，一堆堆蒸煮，有下人无语。红翅飞鸟唯有一人卡夫，对月相连和手指相互，都是在无心日出。横听手指点打勾交接变化，笔走廊上魔术成就尽潇洒，不见到秋千人并到荆州上刻画，烟绝唱万岁千载人生花，聊一首笔写遍古今的